To better understand how carbon dioxide can break down into molecular oxygen, Caltech chemistry professor Tom Miller and postdoctoral fellow Philip Shushkoff created a computer simulation. One challenge in modeling the reaction is that the reacting molecules are very excited, meaning they vibrate and rotate in a complex way, the researchers said. In general, excited molecules can lead to unusual chemistry, so we started with that, Miller said in the statement. But, to our surprise, the excited state did not create molecular oxygen. Instead, the molecule decomposed into other products. Rather, the scientists discovered that extremely bent carbon dioxide molecules, those with an unusual geometry, can be created without exciting the carbon dioxide. This, in turn, would produce oxygen. When Yao and Jayapis smashed the carbon dioxide molecules into gold foil, they electrically charged the individual carbon dioxide molecules and then accelerated them using an electric field. However, Jayapis said the reaction could take place at a slower speed as well, which could account for why there is some oxygen floating high in the Martian atmosphere. You could throw a stone with enough velocity at some CO2, carbon dioxide, and achieve the same thing, he said in the statement. It would need to be traveling about as fast as a comet or asteroid travels through space. Before, scientists thought that Mars' tiny concentration of atmospheric oxygen is probably generated after ultraviolet light from the sun hits carbon dioxide molecules in the red planet's air. Jayapis theorizes, however, that Martian oxygen could also be generated when dust particles, accelerated to high speed in the atmosphere, crash into molecules of carbon dioxide. The reactor Jayapis used is very low yield, generating only 1 or 2 oxygen molecules for every 100 carbon dioxide molecules careening through the accelerator. Jayapis said, however, that perhaps his reactor could be modified one day to create breathable air for astronauts on Mars. And on Earth, the reactor may be useful to pull carbon dioxide, which is also a potent greenhouse gas, and the main driver of global warming, out of the atmosphere and convert it into oxygen. Is it a final device? No. Is it a device that can solve the problem with Mars? No, he said. But it is a device that can do something that is very hard. We are doing some crazy things with this reactor. A paper based on the research, led by Yao, was published last week in the journal Nature Communications. By the way, NASA is about to give oxygen-generating tech a test run on Mars. A technology demonstrator called MOXIE, Mars Oxygen in Situ Resource Utilization Experiment, will fly aboard the agency's 2020 Mars rover, which is scheduled to launch next summer and land on the Red Planet in February 2021. MOXIE will split atmospheric carbon dioxide electrochemically, and NASA wants to see if the method could be scaled up to help support people on the Red Planet. So that's IT for today, guys. Watch our more videos.
Inspiration.